மீட்டிங் அகைன். ரொம்ப ரொம்ப நாளா அந்த டைம் சீரீஸ் பத்தி படிச்சிட்டு இருந்தோம். ஸ்டாக் ப்ரெடிக்ஷன்லாம் பத்தி பேசிட்டு இருந்தோம். இட்ஸ் பீன் அ வைல். ஐ திங்க் வி ஷுட் கோ பேக். வெதர் ப்ரெடிக்ஷன் நடுவுல ஒரு தாட்டி பேசணும்.
Yes, there's also a time series data. Yeah, well pointed out.
ஸோ இது எல்லாத்துக்கும் அப்ளிகேஷனா இருக்கிற அந்த பேசிக்ஸ் வந்து திருப்பி லெட்ஸ் கேட்ச் அப் ஆன் இட்.
Yes.
What are you going to talk about today?
Yes. I think the whole world is a time series, இல்லையா?
என்ன எதுக்கு இது தேவையில்லாம் இவ்வளவு பெரிய பிலாசபிலாம்?
So அது வந்து நம்ம வந்து you can look at it as a philosophical way. Can we model the whole world, this time series, which we can't understand?
வேண்டாம், உலகம் தாங்காது.
அது வந்து பேக்வர்ட் ப்ரோபகேட் பண்ணி கேன் வி கோ பேக் இன் டைம், அதுக்கு ஒரு ஏஐ மாடலை கண்டுபிடிங்கப்பா முதல்ல. நான் ஏஐ பத்தி ஸ்டாண்ட் அப் பண்றதுக்கு தான் லாய்க்கு நினைக்கிறேன். அது நீங்க மட்டும் சிரிப்பு நினைக்கிறேன். சரி, ஓகே. ஆக்சுவலா நம்ம ரீகேப் பண்ணுவோம் நினைக்கிறேன். ஐ திங்க் வி டிட் லுக் அட் ஸ்டாக் forecasting. அதுல வந்து ஃபர்ஸ்ட் வந்து வி லுக்ட் அட் மூவிங் ஆவரேஜ் அண்ட் தென் ஆட்டோ ரிக்ரெஷன் and then a combination of other things. Actually, the main concept is these two methods. Maybe I'll share my screen, then we can go through it pretty quickly. Okay, very good. So we started with moving average process. Just to recap, moving average is then where you're predicting the next time as a combination of the mean of the data times this data, and then some combination of some error terms. அது வந்து நம்பர் ஆஃப் பாஸ்ட் ஆர்டர் ஆஃப் டிட்டர்மைன்ஸ் எவ்வளோ பேக் வரும். இஃப் ஜஸ்ட் MA 1 we are looking at
time instances.
Yes, very good. Yeah, MA 1 we are looking only the past time, past t-1. If it is 2 we are looking up to t-2, then we can go up to q actually.
Q வரைக்கும் போட்டுருக்கீங்க. So இங்க வந்து t-q வரைக்கும் போகுது.
This is the first method we looked at. Similarly, this next one is auto regression, follows the same principle. But here, the model is a combination of a constant term plus an auto regression terms. Same y minus t, yt minus 1, yt minus p. Previous moving average, we are used error terms and mean. Here it is constant, it is an auto regression. Regression is looking at itself, auto regression is. So what is the current value of this time series depend on the previous values, t-1, t-2, t-p on its own actually. Again, the order p determines number of terms, past, previous terms, it will depend on. So it's the basics actually.
So போன இதுல வந்து it directly depends on the error. இங்க வந்து instead of error பண்றதுக்கு பதிலா predicted values வச்சு you are trying to predict the next value.
Exact previous values வச்சு you are trying to predict the next value. Previous historical auto regression. The name itself says that we are regressing the same variable against how the variables previous the current value depends on the previous values. That's regression, auto regression. Okay, so these are the two methods. In the methods one policy is that you have to make the time series stationary so that you can predict it very well. As a stationary ஆக்கிறதுக்கு one of the standard method we use integration. First one you differentiate it, and then when you want to forecast you integrate it. Okay, so you can combine these two, MA and AR, along with the integration. We called it SARIMA. Okay, so that is the last thing we saw, where we combined both auto regression and moving average, and then we added integration on top of it. We call this SARIMA. Okay. SARIMA is nothing but
auto-regressive integrated
moving average model. Okay, where yes. So the important thing is the AR terms la irukku, where error terms la inga irukku, AR terms, moving average terms la ingeyum irukku. Sorry, so this is moving average, this is AR terms. So we are combining all these terms with a constant at the starting, and இத வந்து நம்ம differentiate பண்ணி integrate we are trying to predict the differentiated time series and not the exact time series. differentiate பண்றதுனால என்ன ஆகுதுன்னா the model becomes stationary. That is the ARIMA. This is the last thing we saw. அதுல ஒரு bug I think you pointed out very well. I think it was not working and we figured out that you don't have to differentiate once, but you have to differentiate twice to actually get a more stationary model. And we saw the prediction also was very good. Okay.
Oh, okay.
Okay. So this is the basically the ARIMA model we stopped. The next one we are going to see is look at is the SARIMA actually. SARIMA na you can pretty much guess what is SARIMA actually. Any guesses, Nithilan?
அதான் இங்க போட்டு காட்டிட்டீங்களே, சீசனல் ஆட்டோ ரிக்ரெசிவ்.
Okay, in the SARIMA model actually, நம்ம பாத்தீங்கன்னா we are just looking at the time series data as a single long series. But நம்ம வந்து we have some seasonality in the data இல்லையா? The stock data might not be very seasonal, but still we have some seasonal data.
சரிமா அப்படின்னு சொல்ற மாதிரி இருக்கு.
உண்மையாலுமே சரிமா தான். ஸோ அந்த சீசனாலிட்டிக்காக நம்ம எக்ஸ்ட்ரா டேர்ம்ஸ்லாம் ஆட் பண்றோம். ஓகேவா? வேர் திஸ்
சீசனல்ன்றது என்ன அர்த்தம் இதுல இங்க? So there are some, is it SATA?
Yeah, this is a very good example here in the bookல இருக்கு. Number of air passengers every year actually is steadily increasing. Even now it is increasing. Number of air passengers increases every year. Number of airplanes increases. Number of airports increases. But the amount of passengers traveling every year is a seasonal one. இல்லையா? Actually, in the summer, the amount of passengers increases, and in the winter, it goes down. Obviously, during December, not many people travel. So there is a seasonality here. ஓகேங்களா?
Okay, அதே மாதிரி ஒவ்வொரு டேட்டாலையும் prediction.
So if you understand the seasonality, you can predict the next season very well as well. இல்லையா? So we are adding an extra component for seasonality here. That is the main point of SARIMA. ARIMAல வந்து we are looking at the whole thing here with AR and MA. SARIMAல வந்து for this season, particular this season, ஒரு சீசனுக்கு என்னென்ன, what is the moving average, what is the differentiation to use, what is the AR terms to use, அந்த ஸ்மால் சீசனுக்கு நம்ம தனியா ஒரு மாடலிங் பண்றோம். That is SARIMA.
Okay.
So the captured by the seasonal parameters PDQ actually. The capital PDQ, small PDQ are the parameters of the ARIMA model. ஓகேங்களா? Where capital PDQ is that of the seasonal parameters கான தனியா model parameters.
So they are still do the same thing, like
yes, so they take a small window, and within that window they will predict what is the AR model, what is the MA model to use, and also what type of differentiation to use. அதுக்கான hyper parameters தான் the PDQ.
Okay.
Maybe you can look at the seasonality here. So every small season you have a separate model for each season, and this get repeated. So it is a two-step model வச்சுக்கலாம். ஓகேங்களா? One, there is a overall model which looks at the whole trend, and one which looks at the single seasonal trend also, so that it can predict the next seasonal trend very well. Okay. So I think with this introduction, probably we can look at how it will work for let's say stock market prediction. Let's start with Walmart. Walmart data வந்து we can look at it. This is the 5 years data. So do you see any seasonality here, Nithilan?
கொஞ்சம் கஷ்டம்தான். ஏதோ ஒரு சீசனாலிட்டின்னு சொல்ல முடியல எனக்கு பெருசா. I see that there is a constant increasing in ஒரு trend இருக்கு. But otherwise, I don't see a big seasonality.
Very difficult to figure out the season, yeah, because obviously stock market doesn't depend on the season. There are 100 other parameters. There is some seasonality to it as well, but I think obviously there is no clear seasonality here. நம்ம வந்து இதை வந்து obviously we can split it out into yearly data பிரிச்சோம்னா I don't see a clear seasonality here actually. Obviously there may be some dips here which we can here and there see. Maybe there is a dips every year at the start of the year. There is some dips. Okay, இங்க ஒரு dip இருக்கு, இங்க ஒரு dip இருக்கு, இங்க ஒரு dip இருக்கு, இங்க ஒரு dip இருக்கு, இங்க ஒரு towards the air it always goes high
ரொம்ப
during the
கிளியரா
descent.
வந்து சீசன் இருக்க மாதிரி தெரியல. பட் தேர் இஸ் சம் பேட்டர்ன். லைக் ஏன்னா நம்ம கண்டினியூஸா இன்க்ரீஸ் ஆயிட்டு தான் இருக்கு. பட் ஆனா கண்டினியூஸா இன்க்ரீஸ் ஆனா எல்லா தாட்டியும் இன்க்ரீஸ் ஆயிட்டு இருக்காருல்ல. தேர் ஷுட் பாயிண்ட்ஸ் வேர் இட் டிப்ஸ் டவுன்.
Yes,
As you
every
said,
yeah, there is obviously
increases, then there is a
we
dip.
can't see
Then
any
there increases, there is a dip. So
dip, but there is a dip and goes up. But obviously, Nithilan, you are correct. We don't see a proper seasonality. So again, we are following the same things here. I think we are looking for stationary things. We are not going to repeat. நம்ம அதெல்லாம் skip பண்ணிடலாம். Then actually, here again, this is first two-step process. ஓகேங்களா? First, we have to identify what is the small PDQ value to use and what is the big PDQ value to use. ஓகேங்களா? அதுதான் சரிமால் important thing.
இத வந்து நீங்க ஒவ்வொன்னுத்துக்கும் ட்ரை பண்ணி பார்த்து எதுக்கு பெஸ்ட் ஃபிட் ஆகுதோ அதுக்கேத்த மாதிரி வேல்யூ பாராமீட்டர் சூஸ் பண்ணுவீங்களா? இல்ல இது
Exactly. அதுதான் வந்து சொல்றாங்க ஆக்சுவலா. For all this value, there is a for any model which is fitted actually, there is a value called AIC, meaning that this AIC value will tell us whether these hyperparameters are a good fit or not. For each fitted model, you will get an AIC value, and then you can from that you can choose the hyperparameter which is gives that lowest AIC. Then that is the best fit.
looks like AIC, which is Akaike information criterion. It evaluates how a model fits a given data set. So
Very good.
in case you have multiple hyperparameters and each of the model produces different outputs, you want to identify which model better fits the data அப்படின்னு கண்டுபிடிக்கிறதுக்கு ஒரு it's a number.
Yeah, this is very important number actually. Because I think last time you remember we struggled with what is the value of D. D is the how many times you have to differentiate and integrate. நம்ம அது one time பண்ணிட்டு அப்புறமேட்டு we figured out after a week of effort that is you have to do it twice to make it stationary. So this AIC value is a good thing where you can feed different values of P, D, Q and figure out which is the order for autoregression, which is the order for moving average to use, and how many integration you use. Okay. So this is a thing we can automate easily. And then similarly, we have to do it for also the seasonality. So there is a two-step stage. And you want to play around with 6 parameters, it will take ageless ever and ever. Yeah. 6
Correct.
parameters, number of combinations increase of the. I want to first warn you one thing that these SARIMA models are very slow. Okay. These SARIMA models simply run at least 2 hours. At least for these, even the small data set.
Oh, really?
Yes.
So
yes.
How big is your like number of years எவ்வளவு யூஸ் பண்ற நீ?
I had 5 years. So each year had close to 250 data set. So 250 into close to 1500 data set. But if you want to run a full SARIMA, okay, run a single instance of one SARIMA with all the ARIMA parameters and also the seasonal parameters, it will take hours. Okay.
Okay.
This can't be run easily. So these SARIMA models are very expensive.
Is this with the variation or is it just one PDQ combination?
One combination of small PDQ and capital PDQ will run for a couple of hours. Okay.
Wow.
Whereas if you only want to try ARIMA with these parameters with only small, that runs within minutes. That's not a problem. Okay. That is something you have to start with. So this